Good morning, everybody. Can you hear me?
Yes, sir.
I'm sorry we are a bit late because there were some problems with the system. So today, before I start, we actually have to start a new topic. But before I start a new topic, I was just yesterday going through the tutorial that has been given to you. I would like to just show you some numericals which will help you in solving the tutorial. You write down an example. Today is 21st. Construct state model for the system shown in figure 1. This is the system. This is the system for which you have to construct a state model. You have to follow the same rule that we have been following for constructing state models. The rule is that the outputs of the integrators are to be chosen as state models, state variables. There is no pure integrator here, but it is the transfer function of an integrator block with some other term also. 1 upon s plus 1 here, 1 upon s plus 2. So these two block outputs you have to take as a state variable. Like this we will call as x1, and the output of this block we will call as x2. Because this 1 upon s plus 1, if you see this, I can always represent it like this. Can I show it like this? This is your GS, and HS is 1. The feedback loop, what is the transfer function of this loop? GS upon 1 plus GSHS. That is 1 upon S upon 1 plus 1 upon S. That is actually 1 upon S plus 1. Is that okay? So there is a what you call integrator in this block, hidden in this block. So the output of this block will take a state variable 1, and the output of this block will take a state variable 2. There are two such blocks here, so there will be two state variables. And now we will write down the equations. Now tell me, what is this signal here? This one? Yes.
U minus x2.
U minus x2, very good. U minus x2. So I write down the equations now. So what is x1 equal to? x1 is equal to 1 upon s plus 1 into u minus x2. Isn't it? Or I can write s plus 1 into x1 is equal to u minus x2. Or I can write sx1 plus x1 is equal to u minus x2. Sx1 is what? What is s times
One dot.
x1? Yes?
X1 dot.
x1 dot. Very good. Plus x1 is equal to u minus x2. Or I can write x1 dot is equal to minus x1 minus x2 plus u. This is your equation number 1. Is that okay?
Yes, sir.
Now equation number 2. Now I write down the equation for x2. So this is x1 here. This signal, the input to this block, that is transfer function 1 upon s2 s plus 2. The input to this block is x1. So I can write down the equation as x2 is equal to 1 upon s plus 2 into x1. Are you getting me? Or I can write s plus 2 into x2 is equal to x1. Or I can write sx2 plus 2x2 equal to x1. Or I can write x2 dot is equal to x1 minus 2x2. This becomes your equation number 2. Okay. Now I can write these two equations in matrix form. That will give me the state equation. Writing equation 1 and 2 in matrix form, what will I get? x1 dot x2 dot is equal to, yes, help me, minus 1, then 1 and minus 2, then x1 and x2 plus 1, 0, u. Is that okay? Is that clear?
Yes,
Yes,
sir.
sir.
Now I write down the output equation. Now tell me what will be the output equation? Output equation will be y is equal to the sum of these two signals. That is x1 plus this. That's plus u minus x2. So y is equal to x1 plus u minus x2. Or I can write y is equal to x1 minus x2 plus u. So if I write this in matrix form, what will I get? Y is equal to y is equal to 1 minus 1 x1 x2 plus u. Is that okay? So these two equations together, this is your state equation and this is your output equation. ये दो इक्वेशन मिलके आपका, इसमें आप यहाँ पे ऐसे भी लिख सकते हो, if you want, you can write 1 into u. So this becomes your output equation. These two equations together make up the state model for the system. Is that okay? Is that clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now tell me one thing. If I convert this state model into a transfer function, what type of transfer function will I get for the system? In terms of the degree of the numerator polynomial and the denominator polynomial.
Strictly proper, sir.
We will get a strictly proper transfer function. Isn't it? Because in this case, d is non-zero. We have seen that when d is non-zero, we get a strictly proper transfer function for the system. Strictly proper transfer function means that we'll have the degree of numerator polynomial same as the degree of the denominator polynomial. Can you verify that? Can you convert this into transfer function? अगर मैं इसका ट्रांसफर फंक्शन ऑब्टेन करूं क्या होगा वो? What's the formula for that? Formula for that is GS is equal to, yes, help me.
A into SI minus A inverse
It's not
B.
A. It is C into SI minus A inverse of B plus
Plus
D.
B.
Just do this and tell me what will be the transfer function of this. जरा करके दो ये जल्दी. पहले SI minus A inverse obtain करो, then do this C SI minus A inverse of B and then add it to D, and then tell me what is the transfer function of the system. Roll number 1. Who's roll number 1?
Yes, sir.
Tell me, do it fast. I want the answer from you.
Yes, sir.
I want the solution of this problem from you.
Best I am doing, sir.
Yes, do it fast. What's your name?
Rai, sir.
Reis. Okay. इतने छोटे प्रॉब्लम में इतना टाइम थोड़ी लगता है.
Excuse me, sir.
Yes.
लिखिए, sir.
हाँ जी.
S square
S square
plus S
plus S.
plus 4
Yes.
upon S square plus 3S plus 1.
Has anybody else done it? Please cross check. एक बात तो कंफर्म हो गई कि स्ट्रिक्टली प्रॉपर ट्रांसफर फंक्शन आ रही है, न्यूमरेटर डिनोमिनेटर का सेम डिग्री आ रहा है जैसे हमने प्रेडिक्ट किया था.
Yes, sir.
But just check whether the answer is correct. I don't have the answer to this. Somebody else, please cross check it.
सर एस स्क्वायर प्लस 4s प्लस 4 है शायद.
तो दो आंसर्स आ गए, तीसरे में कंफर्म करना है.
So s square plus 4s plus 4 whole divided by s square plus 3s plus 3. वो 1 के जगह पे 3. हाँ सर.
तो तीन लोगों के तीन आंसर्स आ गए.
So even I got the same answer. In the place of 1, it is 3.
Just repeat what is the answer.
S square plus 4s plus 4 by s square plus 3s plus 3.
डिनोमिनेटर में सर 1 की जगह 3 आएगा.
ठीक है, ठीक है. So this is the transfer function. Okay. Now tell me what are the poles of the system and what are the eigenvalues of the system. Poles भी obtain करो, eigenvalues भी obtain करो. Poles कैसे obtain करोगे आप? Yes.
सर डिनोमिनेटर रूट्स ऑफ डिनोमिनेटर.
Denominator equation बनाओगे आप, characteristic equation जिसको कहते हैं, और उसको solve करके you'll get the poles, isn't it? So you have this equation s square plus 3s plus 3 equal to 0. Just solve it and give me the values of poles. Is the system underdamped, overdamped, or critically damped? Quadratic equation solve करने में इतना टाइम लगता है क्या? Tell me what is this?
सर माइनस 3/2 प्लस अंडर रूट ऑफ 3/2 आयोटा.
Minus 3 by 2 plus minus
अंडर रूट ऑफ 3/2.
under root of
सर
3.
सर अंडर रूट ऑफ 3 डिवाइडेड बाय 2.
ऐसे
यस सर. आयोटा सर आयोटा.
आयोटा लिखा हमने. आयोटा की जगह हम जे लिखेंगे, ठीक है? तो बताओ मुझे इसके पोल्स की लोकेशन एस प्लेन में. This is sigma, this is j omega, this is your s plane. What is the location of poles? It's minus 3 plus minus 3 upon 2 plus minus root 3 upon 2. So it's somewhere here. Isn't it? इसका जो रियल पार्ट है वो क्या है? Minus 1.5. और इसका इमेजिनरी पार्ट क्या है? 0.866. Is it? है ना?
Yes, sir.
So the poles are located in the left half of the S plane. Is the system stable or unstable?
Stable.
The system is stable. अब इसके आइगन वैल्यूज ऑब्टेन करो. आइगन वैल्यूज कैसे ऑब्टेन करते हैं? You solve this equation.
Lambda I minus A determinant equal to.
है ना? निकालो इसका कैरेक्टरिस्टिक इक्वेशन क्या आएगा? use common sense. There is no pole zero cancellation here.
Sir, same.
Sir.
Lambda is also
It
same.
will be lambda square plus 3 lambda plus 3 equal to 0, isn't it?
Yes, sir.
Yes,
That
sir.
is the characteristic equation and lambda इसके जो आइगन वैल्यूज होंगे वो भी सेम ही होंगे जो हमने ऑलरेडी प्रूव भी किया और हमने आपको ऑलरेडी स्टेट भी किया है वो कि जब पोल जीरो कैंसिलेशन नहीं हो in that particular case the set of eigenvalues is same as the set of the poles of the transform, isn't it?
Yes, sir.
Is that okay?
Yes, sir.
ठीक है अभी हम दूसरा न्यूमेरिकल देखते हैं. Then write down one more. Construct state model for the system shown in figure 2. So we'll take example 2. Construct state model for the system shown in figure 2. Figure 2 is something like this. There's a plus with minus this is u. Then you have 1 upon AC. Like this. This plus. We have 1 upon S plus 1 here. Equals here. This is plus. This is 1. And then I have 1 upon S plus 2. Have you drawn it? इसमें बताओ कितने स्टेट वेरिएबल्स होंगे सेम लॉजिक यूज करके सेम फॉर्मूला यूज करके the outputs of the integrated blocks are to be taken as the state variables. So this is one block, I'll call this at x as x1. This is another block, I'll call this as x2. Okay, and this is another block, I'll call this as x3, like this in uppercase because these are the Laplace variables. Okay, are you following me?
Yes, sir.
Yes, sir.
Okay. अब बताओ क्या इक्वेशंस बनेंगी इसकी. अगर ये x1 है तो ये वाला वेरिएबल क्या है? This is actually u minus x3, isn't it? This signal here.
U minus x3.
This is u minus x3. And this is also equal to, because this is 1 upon s here, this is also equal to x1 dot. Because if this is x1 and there is 1 upon s here, so this must be x1 dot.
Yes, sir. Yes, sir.
ठीक है ना?
Yes, sir.
ये x1 डॉट होना चाहिए. तो हम कैसे लिखेंगे इक्वेशन? राइट डाउन u minus x3 is equal to, yes, u minus x3 is equal to there's a correction, there's a slight correction here. It's like this. I'm sorry. Okay. U minus x3 simply equal to x1 dot. सही है ना? और s times x1. I can write x1 dot is equal to minus x3 plus u. This I will call as equation number 1. And what is x2 equal to? Or we'll do it a bit differently. Just wait. Let's not do it like this. So as you can see here, this is u minus x3 here. And this u minus x3 is going as an input to this. So you have got actually x2 is equal to 1 upon s plus 1 into u minus x3. Or I can write s plus 1 into x2 is equal to u minus x3. Or I can write s x2 plus x2 is equal to u minus x3. So writing in correspondingly in time domain, what will I get? I'll get x2 dot plus x2 is equal to u minus x3. Please note down the change in the case of the letters. Or I can write x2 dot is equal to minus x2 minus x3 plus u. ये मुझे x2 dot वाला equation मिला. I call this as equation number 1. Okay. Is that okay?
Yes, sir.
Okay. Now we have to write down the other equations. Now I write down the equation for this is your x2 dot. So what is x2 dot coming out to be? X2 dot is coming out to be minus x2 minus x3 plus u. Now what will be the equation for x1 dot? Or let me write down the equation for x3 dot first. So ये दूसरा वाला equation जो हो गया ये वाला. This one. What is the signal here?
X1 plus X2.
This is
X1 plus X2.
है ना? This goes as an input to this block. What is x3 equal to then?
1 by S plus 2 into X1 plus X2.
Very good. 1 by s plus 2 into x1 plus x2. Or I can write s plus 2 into x3 is equal to x1 plus x2. Or I can write sx3 plus 2x3 is equal to x1 plus x2. अब अगर इसको टाइम डोमेन में लिखेंगे तो कैसे लिखेंगे? Or I can write x3 dot plus 2x3 is equal to x1 plus x2. Or I can write x3 dot is equal to x1 plus x2 minus 2x3. Is that okay? This becomes your equation number 2. This becomes your equation number 2. सही है ना?
जी सर.
Okay. Now the equation for अभी x1 dot की equation पढ़ी हुई है ना? अभी x1 dot की equation नहीं मिली मुझे. What is the equation for x1 dot? Let's see. The equation for x1 dot is, yes, help me.
U minus X3.
x3.
X1 dot is also x1 dot is u minus x3, है ना? Or I can write like this: x1 dot is equal to minus x3 plus u. This becomes my equation number 3. Now these three equations I can write down in matrix form. x2 dot equation कहाँ पे मेरी? That's here. Let me write it here. I have got x1 dot, x2 dot, and x3 dot is equal to, देखो पहले x1 dot minus x3 plus u. कैसे लिखेंगे? 0 0 minus 1 है ना? Plus u भी है, so this is actually x1 x2 x3 plus u है, so this is 1 and this is u here. Is that okay? Now x2 dot is minus x2 minus x3 plus u. So this is 0, minus 1 and minus 1 and plus u, it's 1 here. Then you have x3 dot is equal to x1 plus x2 minus 2x3. x1 plus x2 minus 2x3 और इसमें u वाली टर्म नहीं है, this is 0. Is that okay? सही है?
Yes, sir.
बनाइए स्टेट इक्वेशन. ये बन गया आपका स्टेट इक्वेशन. And what about output equation? What is the output equal to? x1 plus x2.
x1
है ना? Output equation is y is equal to x1 plus x2. तो लिखो इसको मैट्रिक्स फॉर्म में. So that's y is equal to 1 1 x1 and x2. u है नहीं इसमें. So this becomes
सर जीरो भी XE के लिए सर जीरो मत.
yes, very nice, very nice. Because there is no x3 here, so this will actually be 1 1 0 x1 x2 and there is no u here, so this becomes your output. सही है? तो अगर इसको ट्रांसफर फंक्शन में कन्वर्ट करेंगे तो कैसा ट्रांसफर फंक्शन मिलेगा?
proper
We'll get a proper transfer function. That means the degree of numerator polynomial will be less than the degree of the denominator polynomial, isn't it? तो इसमें वो आप कर लेना खुद ही, देखना इसमें वो जो सारे एक्सरसाइज हमने प्रीवियस प्रॉब्लम के लिए किया था, पहले इसका ट्रांसफर फंक्शन आप ऑब्टेन करोगे, फिर इसके पोल्स ऑब्टेन करोगे, फिर इसके जीरोस ऑब्टेन करोगे, फिर इसमें e to the power 80 ऑब्टेन करोगे. Can you do that? What is e to the power 80? What is this known as? Yes, roll number 2. Who is roll number 2? Roll number 2. Present है क्या? कि मैं एब्सेंट मार्क करूं? Who is roll number 3? Roll number 3. Roll number 4. Can you hear me?
Yes, sir.
Who is roll number 4? Roll number 5. 6.
Three है. Mehran.
Roll number 3. Unmute yourself. Roll number 3. Can you hear me? Four है.
4 नहीं 7 है.
Roll number 7.
Yes, sir.
You're roll number 7. What's your name?
Sir, Jahangir Saini.
Tell me what's e to the power 18 known as?
Sir, it is state transition matrix.
State transition matrix. How many methods have I shown you to compute the state transition matrix?
three methods.
Three methods. So which method are you more confident with?
Laplace and Cayley-Hamilton method.
Cayley-Hamilton method. Okay. What do we do in Cayley-Hamilton method?
So first of all, we'll assume this a to power 80 equal to fa, and we will form its corresponding scalar. Then after, according to the degree of the transfer matrix, we'll convert it into in the form of like beta naught plus lambda beta 1 up to so on. Then we'll calculate the eigenvalues of the A and substitute in lambda, solving the equations, getting the value of the constants beta naught, beta 1, and like whatever the constants are there. Then in the that FA form, in the matrix form, we'll put it and solve to get the e to power 80.
Very nice. Very good. Roll number three, sir. Is rule number three still absconding? क्या वो CR है?
पता नहीं सर.
Rule number 3 is the CR.
सर वो मैसेज कुछ कर रहा है,
क्या कर रहा है?
मैसेज में कुछ लिखा हुआ है.
क्या लिखा है? जरा
उन्होंने-
देखो क्या लिखा है.
शायद अगर अनम्यूट कर लूँ. बोल रहा है कि मैं अनम्यूट ही हूँ, लेकिन इसमें तो म्यूट दिखा रहा है.
क्या लिखा है?
बोल रहा है सर मैं अनम्यूट.
You are not unmute. इसमें तो म्यूट दिखा रहा है आपको. Rule number 3. Rule number 3. Don't play games with me. Is he the CR? Is he the same guy who happens to be the CR of this semester? Yes, rule number 1. Raise.
यस सर.
यही है CR क्या?
जी सर.
ठीक है, इसको हम देख लेंगे आप. Now let's do one more numerical. Write down the state diagram of a linear system. The state diagram of a linear system is shown in figure 3. Assign the state variables. Assign the state variables and formulate the state model. So your state diagram is given in the form of a signal flow graph. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is your variable u, and this is y here. It's like this. This is 1. This is s to the power minus 1. This is again 1. This is s to the power minus 1. Again s to the power minus 1. This is 2. This is 1 and this is 2. This is minus 1. This is minus 2. This is minus 1. And then this is 1. and this is minus. The state diagram of a linear system is given in this form, in the form of a signal flow graph. We have to assign the state variables, and then we have to write down this, formulate the state model for the system. We have to formulate the state model for the system. Now, what is the rule that we use for for assigning the state variables?
Sir, output of integration.
Integrators are to be chosen as state variables. So, how many integrators are here?
3, sir.
3 integrators. This is one integrator, this is second integrator, this is third integrator. Isn't it? Now I name the outputs of these integrators as state variables. So this node represents the output of this integrator. I call this as x1. Okay? The output of this integrator, I call this as x2. And the output of this integrator, I call this as x3. Is that okay? So if this is x1, what is this variable?
X1 dot.
X1 dot. So this will represent x1 dot. Or this will be sx1, isn't it? ये वाला जो वेरिएबल है ये रिप्रेजेंट करेगा ना sx1 ऐसे.
Yes, sir. Yes.
And this one will represent
sx2.
है ना? तो ये वाला रिप्रेजेंट करेगा sx3. सही है?
Yes.
Now let me write down the equation. Let me write down the equation first of all for sx1. What will be sx1 equal to? Just help me. So sx1 is equal to u. ठीक है ना? Then minus x1. Then minus x2. और
minus y.
y नहीं. ये वाला आपका एक्सिस के फॉर्म में लिखना है ना. x3 देखो इसके साथ कैसे कनेक्टेड है. x3 ऐसे कनेक्टेड है 2 और -1 के थ्रू है ना. This is actually -2 x3. ये सिग्नल आ रही है ना यहाँ पे. ये वाला नोड क्या है? यहाँ से यहाँ पे ये x3 है. What is this node then? Yes, tell me. अगर ये x3 है तो ये वाला क्या होगा? 2x3 and this is also 2x3. Isn't it? So in time domain, how do I write down these equations? I'll write down them as x1 dot is equal to minus x1 minus x2 minus 2x3 plus u. This becomes your equation number. सही है?
सर वो 2x3 के पास शायद समर भी है ना सर. ये मत इंक्लूड करना.
क्या है वहाँ पे?
सर 2x3 के पास सर वो
ये वाला?
सर ऊपर से जो आ रहा है sx2 भी तो आएगा.
अच्छा. सही है. यहाँ पे ये ऐड हो रहा है. यहाँ पे ये दो सिग्नल्स ऐड हो रही हैं. So basically this signal is x3. So the signal here, because one more signal is getting added here. And what is that signal actually? This is actually sx2.
sx2.
Yes. Okay. So this is actually sx2. But this is also equal to ये यहाँ से आ रही है ना signal.
Yes sir. x1 it's also equal to x1.
ये भी x1 ही है ना?
जी सर.
x1 नहीं होगा ना सर वहाँ सर.
हाँ?
सर x1 plus 2 x3 भी तो आ रहा है.
x1 plus
2x3 will be the node.
x1 plus 2x3. So it will be like this actually. तो ये वाला सिग्नल जो यहाँ पर है, so this will be minus 2x3 plus x1. Is it like that? सही है ना? ये वाली सिग्नल जो यहाँ पर है, दिस इज एक्चुअली 2x3 then plus
x1
x1. ये लिखा है ना हमने यहाँ पर. So this is actually 2x3 plus x1. So this will be minus here because it's getting multiplied by -1. ठीक है ना?
Yes, sir.
So because this is getting multiplied by -1 and then it is coming here. So this is basically -2x1 आ जाएगा यहाँ पर. चलिए. Now what is x2? Sx2 की इक्वेशन क्या है?
Excuse me, sir. Sir, can you just explain this equation again?
I'll explain once again. See, we are writing down the equation for this. You have learnt in signal flow graphs that the signal at a particular node is equal to the sum of all the signals entering a node. Last semester you
yes.
had done signal flow graph. तो इसमें देखते हैं कितनी सिग्नल एंटर करेंगी. एक तो ये वाली
Yes.
सिग्नल आ रही है U के थ्रू, और बीच में जो ट्रांसमिटेंस है इस ये वाला जो ब्लॉक है इसकी ट्रांसमिटेंस 1 है. So this will be U into 1, that will be U. Then from x1 there is coming another signal through -1. So this is x1 into -1. There is
Yes,
coming one more
minus
signal from x2. That is x2 into -1. And there is coming one more signal from here. अब ये वाला जो एलिमेंट है, ये वाला जो ब्लॉक है, what is this equal to? We have to see in terms of x1. So you can see here this is x3. And here it's multiplied by 2, so this becomes 2x3. और इसमें एक और एलिमेंट यहाँ से आ रहा है जो कि x1 के थ्रू आ रहा है. तो दिस इज 2x3 plus x1, isn't it?
सर वहाँ पर -2x2 भी तो है.
क्या बोल रहे हो? x1 वाला एलिमेंट यहाँ पे है ना, ये x1 है ना?
यस सर.
ये भी x1 ही होगा.
यस
ठीक
सर.
है, और ये वाला भी x1 ही होगा.
सर बट वो जो SX2 वाला जो पॉइंट है वहाँ पे वो -2 वाला भी तो लूप आ रहा है ना?
-2x2 भी है. Let's do it once again.
यस सर वही बोल रहे हैं.
Yes, you are correct. You are correct. Let's do it once again. Let me rub these things. So this is your x1, this is sx1. It's okay up till now. This is your
Yes.
x1, this is sx1. Let me write down. So how did you जब आपको last time दिखाया गया था स्टेट इक्वेशंस कैसे लिखते हैं, आप कैसे लिखा करते थे सिग्नल फ्लो ग्राफ इक्वेशंस? Let us follow the same path. Let me call this one as, so this is one integrator. The output of this integrator, we'll call this as state variable x1. The output of this integrator, we'll call this as state variable x2. And the output of this integrator, we'll call this as state variable x3. Is that okay? The intermediate variables also we will name. So if this is x2 as we have seen, this one is x2 dot. If this is x3, this one is x3 dot. And these variables also will be naming. Let's call this variable as state variable तो नहीं है. These are not state variables because we have to take outputs of the integrators as the state variables. यहाँ पे ये वाला इंटीग्रेटर है, इसका आउटपुट स्टेट वेरिएबल हो गया. यहाँ पे ये वाला इंटीग्रेटर है, इसका आउटपुट स्टेट वेरिएबल हो गया. There is one more integrator, इसका आउटपुट भी स्टेट वेरिएबल हो गया. So this one is also x1 dot. अगर आप x2 dot की इक्वेशन लिखो, x2 dot की इक्वेशन क्या आएगी? That's very simple. Just tell me what will be the equation for x2 dot?
x1 minus 2x2
x2 dot will be x1
minus 2x2.
minus 2x2. Let me write it simply in small letters. x2 dot is equal to x1 minus 2x. ठीक है ना? And what will be the equation for x3 dot?
x2, sir. x3 is equal. x3 dot is x2.
X3 dot is simply equal to x2 because only one signal is coming here from x2. So x3 dot is x2. Now let me write down the equation for x1 dot. So x1 dot is equal to what? X1 dot is equal to that's this. X1 dot is equal to minus x1. ठीक है, इस पे देखेंगे कौन कौन से सिग्नल आ रही है. Minus x1, then minus x2. ठीक है, ठीक है ना? And then minus this particular signal. So as we have seen that this particular signal is equal to एक तो ये वाला सिग्नल जो है this is equal to 2x3 plus x2 dot. सही है? 2x3 plus x2 dot. ये वाला सिग्नल यहाँ पे. Are you getting me?
Yes, sir.
So this signal is 2x3 plus x2 dot, and that is equal to 2x3. And what is x2 dot equal to? That's x1 minus 2x2. सही है ना? x2 dot की equation है ना x1 minus 2x2. See, I am writing down the equation for this particular node because I have to multiply it by minus 1. So this particular signal is this signal plus this signal. So this signal is 2 into x3 and then this one is plus x2 dot. Are you following me?
Yes, sir.
x2 dot as per this equation is x1 minus 2x2. So this becomes x1 minus 2x2. Now this signal is to be multiplied by minus 1 and added to it. So I multiply it by minus 1 and add it to this. So this will be minus 2x3 minus x1 plus 2x2. Is that okay? So we can write x1 dot is equal to
Sir, plus u. Sir, u भी आएगा plus u.
plus u. So this is minus 2x1 plus x2 minus 2x3 plus u. Now tell me, is it okay? अब बताओ, could you understand this?
Yes, sir.
Yes, sir.
So these become my three equations. This is my equation number 1. This is my equation number 2. And this is my equation number 3. Now I will write down these three equations in matrix form. So what will I get the state equations as? So this is x1 dot, x2 dot, x3 dot is equal to, what is x1 dot equal to? This is minus 2, 1, minus 2, minus 2, 1, minus 2. What is x2 dot equal to? x2 dot is x1 minus 2x2. So this is like this. And what is x3 dot equal to? x2. So it's like this. 0 and 1 and 0. x1, x2 and x3 plus u तो खाली इसमें पहली वाली इक्वेशन में so it's 1 0 0. ठीक है, और आउटपुट इक्वेशन क्या है इसकी? बताओ मुझे आउटपुट इक्वेशन क्या है?
Sir, y is equal to x1 minus 2x2 plus 2x3.
Y is equal to ये वाला सिग्नल,
x1 minus 2x2.
ये वाला, that's simply this 2x3. This is x1 plus minus 2x2 plus 2x3. है ना?
Yes, sir.
So y is equal to what? Y is equal to 1 minus 2 2 x1 x2 x3. Is that okay? तो ये मिल गया आपको स्टेट मॉडल इसका from the signal flow graph. The bottom line is that every time you construct a state model, the outputs of the integrators are to be chosen as the state variables, and then you have to write down the equations for the differential of these state variables, that is x1 dot, x2 dot, x3 dot. That will give you the state equations, and the output equation you will write by writing down the dynamical equation for the output. Is that okay? Is that okay or not?
यस सर।
अब हम एक और एग्जांपल लेंगे जिसमें कि हम मल्टी इनपुट मल्टी आउटपुट सिस्टम लेंगे। Derive a state model. Derive a state model for the two input two output feedback control system. Shown in figure 4. Like this. The two input two output system. ये आपको टू इनपुट टू आउटपुट सिस्टम दिया हुआ है. You have to construct a state model for this. Have you drawn it, all of you?
Yes, sir.
So what is the how do we construct the state model for this? The outputs of these blocks are to be taken as state variables, isn't it? We'll take the outputs of these blocks as state variables. So this is block number 1. Its output we'll call as x1. Okay. इस ब्लॉक के आउटपुट को हम x2 बोलेंगे. The output of this block we'll call as x3. The output of this block we'll call as x4. Is that okay? ठीक है. अब नेक्स्ट हमने इक्वेशंस लिखनी है इसकी. यहाँ पे इस ब्लॉक को इनपुट किया जा रहा है. ये वाले ब्लॉक को इनपुट किया जा रहा है u1. named as u1, isn't it?
Yes, sir.
और ये वाला सिग्नल यहाँ पर क्या है? This one.
Sir, R1 minus X1 minus X2.
Actually, R1 minus Y1 and Y1 is equal to X1 plus X2, isn't it? है ना? So this is basically R1 minus Y1. सही है? So if I write down the equation for X1, what is X1 equal to? X1 is 1 upon S plus 1 into U1. ठीक है ना? Or I can write X1 is equal to 1 upon S plus 1 into what is U1 equal to? It's K1 into R1 minus Y1. It's K1 into R1 minus Y1. ठीक है? Or I can write S plus 1 into X1 is equal to K1 into R1 minus. What is Y1 equal to? Y1 is equal to X1 plus X2. I can write this as, so this will be minus X1 minus X2. Are you following me? Or I can write Sx1 plus X1 is equal to minus K1 X1 minus K1 X2 plus K1 R1. Or I can write X1 dot is equal to, if I take it on this side, this will become minus X1. So I can write minus 1 minus K1 into X1 minus 1 minus K1 into X1 minus K1 into X2 plus K1 into R1. This becomes my equation number 1. Is it okay?
Yes, sir.
X1 dot की इक्वेशन सबकी समझ में आ गई? X1 dot की इक्वेशन हमने कैसे लिखी? पहले हमने X1 की इक्वेशन लिखी. So X1 is 1 upon S plus 1 into U1. U1 is equal to K1 into this. Isn't it? U1 is equal to K1 into R1 minus Y1, where Y1 is equal to X1 plus X2. As you can see here, Y1 is equal to X1 plus X2. So this Y1 I have substituted here, and I have finally got the equation for X1 dot. You can note it down here. Please note it down here that the input here is R1 and not U as you used to have in previous cases. यहाँ पे inputs दो हैं, R1 output R2 और outputs Y1 और Y2 है. Is that clear?
Yes, sir.
Now I write down the equation for x2. What is x2 equal to? Yes, help me. x2 is equal to 5 upon s plus 5 into u2.
U2.
Into u2, or s plus 5 into x2 is equal to 5 into u2, or sx2 plus 5x2 is equal to 5 into, what is u2 equal to? u2 is equal to k2 into, ये वाले सिग्नल क्या है यहाँ पे?
R2 minus Y2.
r2 minus y2, and what is y2 equal to? x3 plus x4, isn't it? Is that okay? So this is 5 into, what is u2 equal to? u2 is r2 minus y2. So I can write this as x2 dot plus 5x2 is equal to 5 into r2 minus, what is u2? y2? y2 is, have we done it
x3
correctly?
plus x4 sir.
नहीं, कहीं पे गलत तो नहीं किया? u2 is actually k2 into r2 minus y2, है ना? u2 is k2 into r2 minus y2. सही है ना? This is 5 into k2 into r2 minus x3 minus x4. Are you following me? u2 जो है, that is k2 into r2 minus y2, and y2 is x3 plus x4. Is that clear? Or I can write x2 dot plus 5x2 is equal to minus 5k2 x3 5k2 x3 minus 5k2 x4 plus 5k2 r2. Or I can write x2 dot is equal to minus 5 times x2 minus 5 times k2 x3 minus 5 times k2 x4 plus 5 times k2 r3. This becomes equation number 2. Any problem in this equation?
No, sir.
तो ये दो इक्वेशन बन गई. अभी और दो चाहिए हमें. 4 स्टेट वेरिएबल्स है ना? अभी x3 डॉट की x3 की इक्वेशन लिखेंगे. व्हाट इज x3 इक्वल टू? It's 0.4 upon s plus 0.4 into u1. Can you write down its equation? Yes.
Yes sir.
Write down. What is x3 equal to? x3 is equal to 0.4 upon s plus 0.5 into u1. 0.4 upon s plus 0.5 into u1. Or I can write s plus 0.5 into x3 is equal to 0.4 into u1. Or I can write s plus 0.5 into x3 is equal to 0.4 times, what is u1 equal to? u1 is equal to, yes,
k1 times r1 minus y1 sir.
k1 times, so k1 we can take out, r1 minus y1. So yeah.
Yes sir.
Or I can write sx3 plus 0.5 x3 is equal to 0.4 times k1 r1 minus y1 is x1 minus x2. ठीक है? Or I can write x3 dot plus 0.5 x3 is equal to minus 0.4 k1 x1 minus 0.4 K1 X2 plus 0.4 KR1. ठीक है ना? We can write x3 dot is equal to minus 0.4 K1 times x1 minus 0.4 K1 times x2 minus 0.5 x3 plus 0.4 K1 it is. K1 ठीक है? ये बन गया इक्वेशन 3. सही लिखा हमने? Are you getting it?
Yes, sir.
Now
Yes,
write,
sir.
now write down equation 4. ये वाली equation. So what is x4 equal to? 4 upon s plus 2 into u2. 4 upon s plus 2 into u2. So it is. Let's do it. x4 is 4 upon s plus 4 into u2. Or I can write s plus 4 into x4 is equal to 4u2. Or I can write s plus 4 into x4 is equal to, what is u2? u2 is k2 times r2 minus y2. ठीक है ना? और I have s plus 4 times x4 is equal to 4 k2 r2 minus x3 minus x4. Or I have x4 dot plus 4x4 is equal to minus 4k2 x3 minus 4k2 x4 plus 4k2 r2. Or I can write x4 dot is equal to minus 4k2 x3. This will become minus 4 here. So this will be minus 4 into 1 plus k2 into x4. ठीक है? Plus 4 k2. अभी मुझे लगता है कि दूसरी इक्वेशन जरा फिर से चेक करो हमने वो सही लिखी कि नहीं. Question number 2. हाँ ठीक है. Is that okay? Are you, did you get this? Would all of you get these 4 equations? At least I need one response.
सर वो ब्लॉक में रिजल्ट 4 अपॉन s प्लस 2 या s प्लस 4
हाँ भाई.
नीचे वाले ब्लॉक में सर. हाँ सर.
देखते हैं x plus 2 है तो इसका x plus 4 बना दो. अब मेरे साथ चेंज करना पड़ेगा. ठीक है? क्वेश्चन में ही इसका x plus 4 बना दो. Is that okay? Now let's write down these equations 1, 2, 3, and 4 in matrix form. So I've got x1 dot, x2 dot, x3 dot, and x4 dot is equal. x4 dot मेरे सामने ही है, पहले यही वाला लिख लेते हैं. So this is 0, 0, minus 4k2 and minus 4 into 1 plus k. ठीक है ना? R2 वाला टर्म छोड़ देते हैं अभी. Then what is x3 dot? x3 डॉट में x1 है -0.4 k1 -0.4 k1 और इसमें x2 भी है -0.4 k1 और इसमें x3 है -0.5 एंड दिस इज 0 x4 है नहीं इसमें सही है ना x2 डॉट की इक्वेशन में क्या है -5 x2 0 ये x1 नहीं है इसमें -5 x2 है और -5 k2 x3 है -5 k2 x3 है और -5 k2 x4 है x2 डॉट की इक्वेशन में ये वाली इक्वेशन में इज दैट ओके यस देन व्हाट इज द इक्वेशन फॉर x1 कहीं पे गलत लिखा मैंने
-1 k1 सर पहले में
हाँ
सर x1 में आएगा -1 k1 सर -k1 सर आएगा x1 में
x1 कहाँ लिखा मैंने अभी x1 में क्या है x1 की इक्वेशन में है -1 -k1 x1 और -k1 x2
-k1 आएगा x2 में सर बाकी 0 0 सर
नहीं x1 में भी है ना -1 -k1
यस x2 में आएगा सर -k1
हाँ this is -1 -k1 this is -k1 and this is 0 and 0 है ना ठीक है then this is x1 x2 x3 and x4 अब इसमें इनपुट्स कितने हैं
2 सर
दो इनपुट्स तो इसमें 2 कॉलम्स होंगे बी वाले मैट्रिक्स में कैसे होगा R1 कैसे आता है R1 R2 है ना x1 डॉट में क्या है
k1 टाइम्स r1 सर
k1 टाइम्स r1 और k2 नहीं है उसमें है ना
सर k2 0
k2 0 so this is k1 and 0 है ना और x2 डॉट में क्या है
5 टाइम्स k2 सर r2 के लिए
5 times k2 r2 so this is 0 this is 5 times k2 ठीक है and what about x3 dot
सर 0.4 टाइम्स k1 r1
0.4 times 0.4 times k1 r1 or
0 सर
0 and what about x4 dot
सर 4 टाइम्स k2 r2
4 times so this is 0 and this is 4 times is that okay
यस सर
तो ये मल्टी इनपुट मल्टी आउटपुट सिस्टम है इसका साइज क्या है इसमें बी का यस व्हाट इज द साइज ऑफ बी 4 cross
2
2 and what is the size of this input vector this is 2 cross 1 so the product becomes 4 cross 1 similarly this is 4 cross 4 here and 4 cross 1 here the product becomes 4 cross 1 so this is how they are compared this is how they are represented is that okay
जी सर
अब बताओ आउटपुट इक्वेशंस आउटपुट्स भी इसमें दो है ना पहले y1 की इक्वेशन लिखते हैं व्हाट इज y1 इक्वल टू
x1 plus x2
x1 plus x2 and what's y2 equal to
x3 plus x4
plus x4 बताओ इसमें कैसे लिखेंगे आउटपुट इक्वेशन मैट्रिक्स फॉर्म so you have got y1 and y2 that's equal to what's y1 equal to x1 plus x2
1 1 0 0 sir
0 0 and this is 0 0 1 and 1 and here it is x1 x2 x3 this is output equation one row corresponds to one input sorry one row corresponds to one output and here One column corresponds to one input. मतलब जितने inputs बढ़ेंगे उतने इस matrix में columns बढ़ेंगे. Are you getting me? Like in this case, there were two inputs, so two columns in this matrix. ये वाले C वाले matrix का size क्या है? It's 2 cross 4. है ना? So this 2 actually, the number of rows corresponds to the number of outputs in this same matrix. If you have 3 outputs, you will have 3 rows. Are you getting me?
Yes, sir.
So if somebody without actually showing you the system shows you the C matrix and tells you, tell me what is the number of input outputs. So how do you tell the number of outputs? By counting the number of rows. Is that clear? Single input, single output system के लिए number of rows 1 होते हैं जो अभी तक हमने सभी numericals किए. इसमें 2 inputs 2 outputs थे तो 2 inputs की वजह से जो B वाला matrix है इसमें 2 columns आए. तो अगर इसमें और भी inputs होते तो उसमें उतने columns बढ़ जाते हैं. तो अगर आपको कोई just state model दिखाए और आपको कहे कि बताओ इसमें number of inputs कितने हैं, number of state variables कितने हैं, number of outputs कितने हैं, you should be able to just by inspecting the state model tell all this information. Is that okay? So this is how multi-input, multi-output system representations are obtained in this. The state variable representations for multi-input, multi-output systems are obtained. Is that clear to all?
Yes.
Yes, sir.
With this background, I guess you'll be able to solve the tutorial. जो लास्ट टाइम ट्यूटोरियल में आपको दिया था जो आपको थर्सडे को सबमिट करना है शायद थर्सडे या फ्राइडे को थर्सडे को so I guess it become easy for you to do that.
Yes.
I don't want more question. Given the system x dot equal to -4, 3, -6 and 5 into x. Determine eigenvalues and eigenvectors and use these results to obtain the state transition matrix. Rule number 8. Who is rule number 8? Let's see what is this. Rule number 9.
Nine.
10.
Yes, sir.
What's your name?
Sana.
Sanna. Okay, Sanna, tell me, obtain its eigenvalues.
Yes, sir, eigenvalues.
Eigenvalues, yes.
Sir, let me calculate.
You will do it fast. All of you do it. So now will tell me the answer.
Sir, 2 minus 1.
2 and minus 1. Somebody else will confirm.
2 and minus 1, sir.
2 and minus. So basically you solve this equation. Determinant of lambda I minus a equal to 0. Now get me the eigenvectors. Rule number 11. 12.
Yes, sir.
Yes, who is rule number 12?
Basel.
Yes, sir. Basel.
What's your name?
Sir, Basel Shaukat.
Okay, get me the eigenvectors. Get me the eigenvector corresponding to the eigenvalue minus 1.
Okay, sir.
आपको कौन सा मेथड मैंने लास्ट टाइम दिखाया था eigenvectors evaluate करने का? Adjoint method I had shown you last time.
Yes, sir.
You compute adjoint of lambda I minus a, then substitute the value of lambda, obtain any one of its columns, that will give the eigenvector.
My job is to make college easier because students have a lot of sorry, coach. Please. And if this force is allowed to act
Danish Ahmed.
on the conductor,
Danish Ahmed.
slow down.
27.
Rule number 27.
Slow down the conductor.
Who is rule number 27? Rule number 27. Yes, rule number 10. Have you done it? Can you hear me?
Yes, sir.
Has anybody obtained the eigenvectors?
Yes, sir.
हाँ जी बताओ eigenvectors क्या है इसके corresponding to -1 क्या है?
-1 it is -6 and -6, and for 2 it is -3 and -6.
Eigenvector corresponding to lambda equal to -1 क्या है?
-6 and -6.
-6 and -6 you could simply write as -1
1 and 1.
है ना?
-1. Yes, sir.
And what about eigenvector corresponding to
-1 and -2.
corresponding to 2 is कितना आ रहा है?
-1 and -2.
-1 and -2. Is somebody else may confirm?
Yes, sir. Yes, sir. These are the answers.
क्लियर है ना?
Yes, sir.
अब आपको ये आइगन वेक्टर्स और आइगन वैल्यूज की इंफॉर्मेशन यूज करनी है इसका स्टेट ट्रांजिशन मैट्रिक्स इवैल्यूएट करने में। ये जो मैट्रिक्स P है इसमें it is actually V1 and V2 which we have said it's -1 -1 -1 -2. If we use this as a similarity transformation matrix, what will it do to matrix A? It will diagonalize it. आइगन वैल्यूज वाला मेथड मैंने आपको दिखाया है ना स्टेट ट्रांजिशन मैट्रिक्स इवैल्यूएट करने का। What is the eigenvalue method of evaluating the state transition matrix? What is e to the power at equal to? हाँ जी जल्दी से।
Sir, P is about lambda TP.
E to the power at is equal to P e to the power lambda t into P inverse, है ना? P तो आपका ये है that's -1 -1 -1 and -2. What is e to the power lambda t equal to? इसमें पता है आपको आइगन वैल्यूज क्या क्या है -1 and 2. So it is e to the power -t e to the power 2t 0 and 0 है ना, क्योंकि इसका जो डायगोनल मैट्रिक्स बनेगा जब डायगोनलाइज करोगे आप इसको डायगोनल मैट्रिक्स में क्या होगा अलोंग द डायगोनल आर -1 and 2. It's like this. So e to the power lambda t will be just raising these to e to the power. So e to the power -t and e to the power 2t. और ये p inverse आप निकाल के when you put it here you will get e to the power 80. Just do it. Obtain p inverse and then solve this. Are you sure its eigenvalues are -1 and 2? Or is it -1 and -2? Yes.
Sir, -1
-1 and
-2.
-2?
सर 2 ही आ रहा है।
No, sir, 2 ही आ रहा है, 2 -1.
We are at.
Yes, sir, 2 -1.
हाँ सर 2 and -1.
P inverse evaluate करके e to the power 80 evaluate करो। पी इनवर्स किया आपने?
जी सर।
पी इनवर्स?
यस सर।
और पी इनवर्स?
So -1
1 minus
हाँ, एक बंदा बोलो क्या है? यस
sir -1 1
1
उस साइड, फिर 2 -1
ऐसे?
हाँ
ठीक है, करो अभी, देखो कितना आ रहा है। Tell me what's e to the power 80 coming out to be? मैट्रिक्स प्रोडक्ट में इतना टाइम लगता है क्या? Yes, tell me, pass.
e power minus t minus 2.
यार फिफ्थ सेमेस्टर, ये तो जबानी कर लेना चाहिए आपको।
हेलो सर, ये इनवर्स हमारा दूसरा आ रहा है। समथिंग आंसर है 2 into e power minus t minus e के power minus 2t।
इनवर्स आपका इनवर्स क्या आ रहा है?
सर मेरा इनवर्स आ रहा है -2 1 1 -1।
Yes sir, -2 1 1 -1
-2 1
1 -1
1 -1 सर फाइनल आंसर है
yes sir, yes sir।
हाँ, क्या आ रहा है फाइनल आंसर?
2 e के power minus t
ओके,
minus e के power minus 2t
ठीक है।
और सेकंड नंबर -e के power minus t।
रो में बता रहे हो?
हाँ सर, रो में बता रहे हैं।
-e to the power
-t
ओके
प्लस e के power 2t
e to the power 2t
और सेकंड में सर 2 e के power minus t -e के power 2t।
ठीक है, यहाँ पे माइनस नहीं, यहाँ पे प्लस होगा। हाँ ठीक है, बताओ।
e के पावर माइनस e के पावर माइनस t
ओके
सर प्लस 2 e के पावर 2t।
जस्ट चेक इट ऑल ऑफ यू।
यस सर ये
क्लियर है? So this is your state transition matrix, isn't it?
सर एक डाउट है सर। आइगन वैल्यूज में तो हमने ऐसा कुछ नहीं है ना कि -1 मस्ट बी द फर्स्ट वेक्टर एंड 2 मस्ट बी द सेकंड वेक्टर, ऐसा तो हम नहीं करते हैं।
नहीं, आइगन वेक्टर जो पहला वाला है ना v1 जैसे है, इट शुड कॉरेस्पॉन्ड टू द फर्स्ट आइगन वैल्यू। ऐसे अगर आपने लैम्डा इक्वल टू
सर बट वी डोंट नो ना व्हिच आइगन वैल्यू इज फर्स्ट, बिकॉज़ 2 भी पहले आ सकता है।
सेकंड की बात नहीं है, फर्स्ट सेकंड की बात नहीं है, लेकिन जब आप इसको इवैल्यूएट करोगे ना लैम्डा को,
हाँ
लैम्डा को जब इवैल्यूएट करोगे तो इसमें जो आइगन वेक्टर आपने पहला वाला लिखा ना,
हाँ
ये वाला आइगन वेक्टर जो आपने लिखा, इसके कॉरेस्पॉन्डिंग वाला यहाँ पे आ जाएगा।
हाँ वो समझा सर, बट जब मैं ना एक्चुअली ऐसा किया हूँ, मैं v1 को अपने लैम्डा 1 को -1 लिया है, राइट। मैंने लैम्डा 1 को 2 लेके किया है, तो मेरा p मैट्रिक्स जो है उसका कॉलम्स इंटरचेंज हो गया, सो मैंने उसके करस्पॉन्डिंग किया।
ठीक है, ओके।
हाँ, सो उसके करस्पॉन्डिंग e का पावर 80 में भी मतलब वो चेंजेस आ रहा है। सो लाइक इज दैट आल्सो करेक्ट या मतलब कुछ गलत हो रहा है बीच में?
गलत तो कुछ नहीं होगा. It will all जो ये प्रोडक्ट फिर आ जाएगा ना इनका, क्योंकि इनका भी कॉलम का भी ऑर्डर चेंज हो जाएगा, इसका भी चेंज हो जाएगा.
Yes. Yes.
Finally it should come out to be same. तो आप चेक करो फिर से.
Okay. Okay.
You check it once again. The complete numerical is solved once again, and then you see, you will finally the state transition matrix will come out to be same.
Yeah. Yes, sir. It's same only. Yeah, I got
ठीक है?
it. Yes, sir.
तो स्टेट ट्रांजिशन मैट्रिक्स को फिर बाद में यूज करके आप स्टेट इक्वेशंस को सॉल्व कर सकते हो. If the initial conditions are given, or if the input term is given, or both of them are given, you can use them to solve the state equation, isn't it? So whatever we have done in the theory so far, I think the numericals have been all the numericals pertaining to that have been solved either in the class, or we have been given tutorials related to that. If you have any issue, you can just contact me either on my personal mail ID, or you can just contact me through WhatsApp, and I'll try to solve your whatever query you have. Is that okay? Yes, tell me.
Excuse me, sir.
Yes, tell me.
Sir, can we get some 1 or 2 day extension in submission for the tutorial sheet?
Why?
So because we had like बहुत सारे assignments इन्हीं 2-3 दिनों में complete करने थे, and we had lab.
You have to manage all these things. You are an engineering student. You have to do all these things. You have to meet the targets. How many hours are you putting up per day in your studies?
So the thing is, recently Javed sir gave us a tedious task to submit all the lectures which we have completed. So our weekend went into completing that only. So now
Why did you not do it? आप साथ ही क्यों नहीं कर रहे थे?
सर साथ कर रहे थे, but लास्ट के कुछ lectures रह गए थे, तो इसीलिए.
You have to manage things. You cannot always push for changing the targets. Change yourself instead. खुद को change करो, ठीक है? Targets को meet करो. If you want to compete with other people. Now, roll number 3. I'll come back to roll number 3. Roll number 3, can you hear me?
Yes, sir.
तुमको क्या इशू था?
सर नेटवर्क में सर प्रॉब्लम अभी भी सर आ रही है बीच में सर.
बीच में क्या हो रहा है तुमको?
सर कट हो रही थी वॉइस सर उस टाइम.
उसी टाइम कट हो रही थी जब मैं पूछने लगा था.
नहीं सर, उससे पहले भी सर स्क्रीन ब्लैक आ रहा था सर. बीच में सर आया मुझे सर ब्लैक स्क्रीन. क्या सर?
Why was this happening?
सर आई डोंट नो. आई थिंक सर मुझे लगता है सर नेटवर्क में सर कुछ प्रॉब्लम है सर. डेटा खत्म हो गया सर.
डेटा खत्म? अब क्या किया डेटा का तुमने? तुम्हें पता नहीं था क्लास है मेरी?
सर अभी भी सर डेटा नहीं है सर. 2G पे चल रहा है सर अभी भी.
मैं कह रहा हूँ डेटा खत्म होने का वेट क्यों किया तुमने? सभी टीचर्स का तुमसे शिकायत, तुम्हारी शिकायत आ रही है सभी टीचर्स से. यू आर नॉट सीरियस इन योर स्टडीज and you claim to be managing your semester, managing your branch. ऐसे नहीं चलेगा. Be serious about your studies. I'll be continuously monitoring you. Okay, we'll stop here. Next वाला topic हम next day को ही start करेंगे. कल start करेंगे. Controllability and observability and stability will take up next time. And whatever queries you have so far, you can just contact us, either me or Danish or Suhail, anybody. So we will try our best to solve your problems. Okay. Thank you all.